This is the second video that's going to be talking about the last two of the 4 atomic structures that we will be covering this year. So what we end up having here is we're going from Dalton's idea of this solid ball, okay, this impenetrable ball or sphere, and every atom has a slightly different sized sphere, and these spheres stick together to make these molecules. Thomson improves upon that idea with his cathode ray experiment, saying, okay, I see your solid sphere, but it's not just one substance. Within that actual sphere, or actually on the surface of that sphere, we have these negatively charged, basically particles that are embedded on the surface. And that gives rise to the blueberry muffin sort of analogy, where the batter of the muffin is this positively charged substance, this solid substance, and the blueberries or the chocolate chips, let's say, are embedded on top, and those are your small little negative particles. What's interesting about Rutherford's ideas, though, because again, this is a progression, and while these discoveries are happening, there is so much other work being done in science and other discoveries being made and new, more powerful machinery that we're able to basically improve upon our scientific experimentation. So Rutherford is really the one who's going to take this kind of atomic structure to the next level. We're going to be done with the concept of that solid ball. Instead, we're going to be replacing it with a ball with a lot of empty space that essentially has its electrons orbiting around this small little dense amount of basically solid material. So in order to explain how Rutherford comes up with this idea, we need to look at his gold foil experiment. So here we've got a really rudimentary drawing of figure 1.11 on page 12 of your text. And this is essentially a recreation of Rutherford's gold foil experiment. Now, what ends up happening here, because during the same time as this, as I mentioned before, there's lots of scientific discovery going on. And one of the things that was hugely worked on was radioactive material. So different types of elements that basically give off radiation. One of those particles that are given off on radioactive substances are known as alpha particles. Okay, so this is the Greek symbol for alpha, A-L-P-H-A. Now, alpha particles are positively charged particles. Okay, just like beta particles are negatively charged and gamma particles are neutral. We're not going to talk about those. We're really interested in this alpha particle. Okay, so what ends up happening here is this gray box over here is actually lead. Now, lead is a really interesting substance because it prevents radioactive material or radiation from moving beyond. It blocks radiation. So what ends up happening, case in point, when you go get an X-ray, they will often place a lead apron over you to protect the different organs in your body that don't need to be subjected to the X-ray. All right, so we've got this radioactive substance in this ball, and it's emitting all kinds of radiation. Now, because of the opening here, all right, we've chosen an actual substance, probably radon, that's emitting these alpha particles. And because there's only one hole in the box, the alpha particles are coming out of it. And they're coming out of it in a stream, and they're just continuing on through this kind of ring of material that on the inside, so on this side here, on the inside here, which is colored kind of in green, all right, it was basically coated with this fluorescent sort of marker in the sense that when something would hit it in terms of these little particles, if they were deflected in any direction, they would hit at some point. Because of this 360-degree ring around it, we could get a 360-degree idea of what happens to the alpha particles as they're shot through a very thin layer of gold foil. Now, thin, I'm talking maybe 2 atoms thick. So here's kind of an idea of the thickness of this substance, where each one of these circles is supposed to be an atom, okay, a gold atom. So this is so much thinner than paper. So what ends up happening here is really, really revolutionary. And it totally defeats any of the ideas that we had of atomic structures afterwards. Because if we assume that all atoms are these solid balls, should anything get through this actual kind of wall of atoms, this gold foil wall? Maybe if the atoms aren't touching one another, like right here, maybe an alpha particle might get through. But in reality, they all should have bounced back. Correct? Correct. So what ends up happening when Rutherford beams his alpha particles through the gold foil, he sees that on the back end over here, that there are actually some hits. His alpha particles, some of them went right through the gold foil, and some of them, their trajectories kind of deflected a little. And some actually even bounced back towards the kind of the entrance of the actual little ring. And this allowed him to come up with 2 ideas. So here we've got a recreation kind of this layer of gold foil. Okay, and you have all of these actual atoms. You can notice that it's only about 3 or 4 layers thick. So it's really, really thin. All right, and the same image is on page 12 of your text. And what ends up happening here, just to show you, the direction of the alpha particles is this way. So they're coming from the left side of the screen and they're moving towards the right. And what was actually seen was that a lot of these actually went clear through one side right through to the other. And so if you've got your phosphorescent ring back here, these were actually lighting up the back screen here. So we would get a light here, a hit. We would get, another hit, let's say like right here. Another hit right here. And we were getting slight deviations as well, okay, that were actually going over here. And some were actually hitting and bouncing right back. So Rutherford, in looking at this, he was gobsmacked. This was huge. And it allowed him to come up with 2 really big discoveries. Okay? 2 major discoveries that are basically accredited to Rutherford. So here, that first major discovery is that basically we noticed that a large majority of the alpha particles that were shot through into that piece of gold foil made it across the actual gold foil. They were not bounced back. They were not blocked by the foil. So that tells us that Thomson and Dalton's idea of the atom being a huge solid ball, whether that ball has, electrons in it or not, this is incorrect. The atom is in fact mostly empty space. Now, for the second big kind of reveal by Rutherford, let's look back at this diagram again, and we see that some of these particles, okay, so some of these alpha particles, when going, were sat there and they were bounced back, and the angle at which they were bounced back was so close to the opposite of the angle at which they were traveling, that Rutherford comes up with the idea that, there's a reason for the fact that these alpha particles are being so strongly deflected and bounced back. And he comes up with the idea that, in order for alpha or positive particles to be thrown back or deflected, well, then something within that atom has to be positive. Because we know from all these cathode ray experiments that like charges repel one another, whereas opposite charges attract one another. And we saw, if we look at this image, we see clear proof of repelling. Okay, and the repelling comes from the deflection. Okay, the change in the path of those alpha particles. So Rutherford comes up with the idea that atoms are going to contain a positive core. This very small but really important and really dense chunk of positive matter. And he says that matter is located at the center of the atom. And he actually coins the term the nucleus. Now, the second thing that he comes up with is that in that nucleus, that is where we're going to find that positively charged material. So he comes up with the notion that the nucleus of the atom is solely positively charged. Okay, so he comes up with that idea that the atom is going to be, its nucleus is going to be positively charged. And we see this when we're talking about Bohr-Rutherford diagrams later on, that Bohr and Rutherford stick with that idea. And if you look on page 13 of your text, you kind of get that Jimmy Neutron idea of the structure of an atom, where in the nucleus with the alpha particles, okay, you've got, this number, this positive 6 within the nucleus, and then outside of the nucleus, so you've got all these electrons spinning around, okay, and nothing is coming near the nucleus, and on these actual structures is where you're going to find your electrons, okay, and the vast majority of this is empty space. So that is Rutherford. The final video will deal with the Bohr-Rutherford kind of combination of what we are using as an atomic model.